I highly encourage you just to pause the video, answer parts A, B, C, and D on your own, and then resume the video and see if you got the correct answers. So here we go. It says part A, what is the length of segment KL? Again, you need to read it as such. What is the length of segment KL? You're going to find that by taking the absolute value of the difference of the two coordinates. So that's 15 minus a negative 9, which is 26. But we could also say negative 9 minus 15, which will give you the absolute value of negative 26, which is all the same. It is 26 units long. Holy goodness gracious. Okay, sorry about that. But it is actually 12:30 at night. So please, please don't hate. I may make some arithmetic errors, so I apologize about that. But goodness. 15 minus a negative 9 is 24, and negative 9 minus 15 is a negative 24. When you take the absolute value of those, you're going to get positive 24. Remember, distance is always positive. It's always positive. Part B says, what is the coordinate of the midpoint of segment KL? To find that, you take the average. So I'm going to say negative 9 plus 15 divided by 2. That's going to give me 6 over 2, which is 3. I'm going to go ahead and label that. My midpoint is 0.3. Part C says, point C lies between points K and L. So point C is somewhere in between K and L. The distance between points K and C is 1/3 of KL. So it says the distance between points K and C. So 1/3 of the length of KL. Well, since we know the length of KL is 24, 1/3 of, that means multiplication, so 1/3 of 24 is equal to 8. So so it says the distance between points K and C is 8. So I'm going to start here at K and move towards L 8 units. If you notice, each tick mark is 3. So this is 3, 6, and then 7, 8. So it's right here at 1. That's where point C is. It then says, what is the coordinate point C? That's just 1. The next part says point N lies between C and L. So now we're considering 1 and, coordinate 1 and 15. So point N is somewhere in between those two. The distance between points C and N is 3/4 of CL. Well, the length of segment CL is the absolute value of 1 and 15, or you could say the difference between 15 and 1. And no matter how you look at it, you're going to get 14. It's pretty late, so I'm just going to make sure that I'm doing this correctly. And I'm not. Okay, no wonder. I'm sorry. Again, it's really, really late. This point C would be at negative 1. I apologize about that. Because if we were starting at negative 9 and we add 8, we're going to get to negative 1. So again, I apologize. But point C is at negative 1. So negative 1 minus 15, or 15 minus 1, that'll get us that the distance between those 2 points is 16. Again, I'm sorry, guys. But so since we know the length of segment CL is 16, 3/4 of, and of implies multiplication, 3/4 of 16. Well, 1/4 is 4, so 3/4 is 12. So if the distance between C and N is 12, and I know that N lies between C and L, so it's got to lie somewhere here, so I'm going to count 12 units this way. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it's going to be here at positive 11. So N is at positive 11. Alright. Moving on, and hopefully I don't butcher any more of this lesson. Sorry about that again. But on page 43 it says, you can use the definition of midpoint and the properties of algebra to determine the length of a segment. So we know what the definition of a midpoint is. We learned that on a previous page. We've been using the properties of algebra. That's like the substitution property, the addition property of equality, the division property of equality, the transitive property, and symmetric property, all of those that we've been learning. We're going to use the definition of midpoint and those properties to determine the length of a segment. And so all of this right here is just a huge example, and it walks you through step by step, and so it's very detailed. It's awesome. So let's go through this together. It says if point Q is the midpoint of segment PR, so stop there, draw a diagram. Please, for the sweet love, get in the habit of drawing a diagram. So I've got point P there, point R there. I got the segment, and I know that Q is the midpoint. So again, I'm going to use that notation of these tick marks to denote that since point Q is the midpoint, then I know that those two parts are congruent. So I can say that segment PQ is congruent to segment QR. Remember, congruence is reserved for objects, same size, same shape. But if that's the case, then I know that, I'm going to kind of move over here. If that's the case, if segment PQ is congruent to segment QR, then that implies the length of segment PQ is equal to the length of segment QR. And that's exactly what it says here. Because Q is the midpoint of segment PR, you know that segment PQ is congruent to segment QR, and that implies that the length of segment PQ is equal to the length of segment QR. Writing math, huge star, huge asterisk. Please don't forget this. Use this notation when you talk about the segment, the object. But use this notation when you talk about the measure or the length of segment AB. Please know the difference between those. So the fact that we know that the length of segment PQ is being represented by 4x minus 5, and the length of segment QR is being represented by 11 plus 2x, we need to know the length of the of this portion. What is this numerical value? Well, since we know that those two parts are equal, which is stated right here, the length of PQ is equal to the length of QR, we're just going to do a little substitution. The length of PQ is 4x minus 5. The length of QR is 11 plus 2x. So I'm going to subtract 2x from both sides. I'm allowed to do that because of the subtraction property of equality. I was allowed to state this statement because I just substituted in. I took this value and plugged it in here, and I took this value and plugged it in there. It's just substitution. I subtracted 2x from both sides. I'm allowed to do that because of the subtraction property equality. I'm going to add both 5 to both sides because of the addition property equality. Divide by 2, divide by 2. Because of the division property equality, I have x is equal to 8. But I'm not done there. Now I know that the value of x is 8. I'm going to take that, and it says now substitute 8 for x in the expression for the length of segment PQ. So the length of segment PQ is 4x minus 5. So rather than having x, I'm going to put 8 in its place. So 4 times 8 minus 5 is 27. Going back to the diagram that we have, if the length of segment PQ is 27, that means the length of QR is 27 because those are congruent, meaning that this whole thing is going to be 27 plus 27, which is 54. And that's exactly what this diagram here says. So try these A. It gives us an opportunity to practice this. So I would go ahead and, you need to pause the video right now and then try A, B, and C on your own. Draw a diagram. Draw a diagram, label what you know. So please go ahead and pause the video and practice and try those on your own. It's okay if you make mistakes. It's okay if you make mistakes. Just learn from them. Okay? I'm going through these together. I've pre-drawn my segment for the first part. It says point Y is the midpoint of segment WZ. So I got my segment WZ here. It tells us that point Y is the midpoint. So this part is congruent to that part. That means segment WY is congruent to segment YZ. That means that the length of segment WY is equal to the length of segment YZ. It tells us that YZ is being represented by x plus 3, and then YZ, the whole thing, is 3x minus 4. So we need to know what the length of segment WZ is, which is the whole thing. Well, since this is congruent to that, the length of WY is equal to, I'm just going to do a little substitution and plug it in right here, is x plus 3. If these two segments are congruent, then they have the same length. So I can represent this as x plus 3 as well. So now I know part plus part is equal to whole. The length of segment WY plus the other part, that's going to equal the whole WZ. So I'm going to plug in what I know. X plus 3 plus x plus 3 has got to equal 3x minus 4. Gives me 2x plus 6 is equal to 3x minus 4. I get that x is equal to 10, but I'm not done. That's not what it asked for. It asked for what is the length of segment WZ. So WZ was represented by 3x minus 4. So WZ is equal to, I'm going to do some substitution, plug in 10 for that. 3 times 10 is 30 minus 4 is 26. It didn't give us any units, so I'm just going to write in units. The next one, RS. Again, I've already pre-made this, so you can pause the video and make them. The segment RS, we have point M as the midpoint, so that means that's congruent to that. It says RM is x plus 3 and MS is 2x minus 1. It doesn't tell us anything about the whole, but that's okay. If this truly is the midpoint, then this length is going to equal this length, so set them equal to each other. And we're going to get that x is equal to 4. So I'm going to plug this value in. When I plug it in, the length of segment RM is 7. The length of segment MS is also 7. So that means the length of RS is equal to 14.